you struggling to predict the major product in elimination reaction? What if I told you that there is a simple rule that can make it super easy? Hi, I am Dr. Swathi. Stay with me till the end of this video to master Saytzeff rule and ace your organic chemistry success. Let me make it crystal clear to you where exactly this Saytzeff rule is important. It is important in elimination reaction. An elimination reaction involves removal of atoms or groups. So this elimination reaction is of again different types: alpha elimination, beta elimination and gamma elimination. In beta elimination or 1,2 elimination, a saturated compound will be converted to an unsaturated compound. So let us consider an example. So this elimination reactions are the characteristic reactions for alcohols as well as alkyl halides. In this structure, when X is OH group, then it becomes an alcohol. On the other hand, when X is a halogen such as chlorine, bromine or iodine, then it is the structure of alkyl halide. So that means either alcohols or alkyl halides, under certain experimental conditions, they will undergo elimination reaction. As a result of elimination reaction, this halogen or hydroxyl group will be removed along with the bonded pair of electrons. Now on the second carbon, hydrogens are present. So hydrogen will be removed without this bonded pair of electrons. Okay. So this pair of electrons will now come to compensate the bond in the form of a double bond. So that is how between 1 and 2 positions we will be getting a double bond. So as a result of which alkene will be formed as the major product. So in this given reaction, there is possibility of formation of only one alkene as the major product. Okay, but in certain alcohols as well as alkyl halides, there will be possibility of formation of many alkenes. Okay, that is multiple number of alkenes as the products. So for example, so here X group is removed from the second position, that can be in a hydroxyl group or halogen. Now the neighboring carbons, if you see, C1 is also having hydrogens and C3 carbon is also having hydrogens. Okay, so in this type of structures, hydrogen can be removed from the first carbon atom so that we get alkene 1 as the product. On the other hand, hydrogen can be removed even from the third carbon atom also. So in that case, we will get alkene 2 as the product. Now out of alkene 1 and alkene 2, which one is the major product? So in such type of alcohols as well as alkyl halides, in elimination reaction, the major product will be decided by Saytzeff rule. So this Saytzeff rule is also known as Saytzeff rule. It is a powerful guideline in organic chemistry that helps us predict the major alkene product in elimination reactions. But why is it so important? Is because it allows us to identify the most stable product quickly and confidently. Now what is Saytzeff rule? Saytzeff rule states that during an elimination reaction, the major product will be the more substituted alkene. That means the alkene with greater number of alkyl groups attached to the double bond will be formed as the major product. So let me show you some examples for substituted alkenes. So the first one is ethene, CH2 double bond CH2. It is an example for unsubstituted alkene because none of the hydrogens of this ethene are substituted with alkyl groups. Now the second one is known as monosubstituted alkene because out of the 4 hydrogens of ethene, one of the hydrogen is replaced with alkyl group. So across the doubly bonded carbon atoms, okay, the molecule is having only one alkyl group. So that is why it is known as monosubstituted alkene. Now, one more hydrogen of this monosubstituted alkene, if it is replaced with alkyl group, say for example, this hydrogen is replaced with alkyl group, then we will get a disubstituted alkene like this. Or if the hydrogen of other carbon is substituted with alkyl group, then we will get a disubstituted alkene like this. So these are the 2 examples for disubstituted alkene. That means with respect to the doubly bonded carbon atoms, if you look at the overall substitution, here it is 2 and here also it is 2. So that is why they belongs to the class of disubstituted alkenes. Now if you substitute one more hydrogen of the second carbon, then we get a trisubstituted alkene like this. So in this structure of trisubstituted alkene, it is left with one more hydrogen. If we replace that hydrogen also with alkyl group, then we will get a tetrasubstituted alkene. So in the structure of tetrasubstituted alkene, if you see, across this doubly bonded carbon atoms, 4 alkyl groups are present. That is why it is known as a tetrasubstituted alkene. So according to Saytzeff rule, highly substituted alkene is the preferred product because highly substituted alkene will be having greater stability due to hyperconjugation and inductive effect. Now how this Saytzeff rule works, let me explain with the help of 2 examples. Example 1 is the dehydration of alcohols. So in this example, I have taken 2-butanol as the starting compound. So the structure is given here. So it contains 4 carbon chain, which is a straight chain having hydroxyl group at second position. Dehydration is one of the characteristic reactions of alcohols. So alcohols undergo dehydration in the presence of strong acids such as sulfuric acid or hydrochloric acid. So if you look at the structure of this molecule, hydroxyl group will be removed from the second carbon. Now coming to the removal of hydrogens, here 2 chances are there. Either hydrogen present at first carbon atom can be removed, that is removal of hydrogen from C1, or hydrogen can be eliminated even from third carbon also. So here 2 chances are there. So upon removal of hydrogen from C1 carbon, there will be formation of 1-butene as the major product because hydroxyl group is removed from the second carbon and hydrogen is removed from the first carbon. So this bond which is previously shared between carbon and hydrogen at first position will be migrating in the form of double bond. So that is how a double bond will be introduced at the first position. So we get 1-butene as the product. On the other hand, there is a chance that hydrogen can be removed from third carbon also. So in that case, this hydrogen is removed and the bond which is shared between carbon and hydrogen at third position will be migrating to second and third position. So in that case, we will be getting 2-butene as the product. Now out of 1-butene and 2-butene, which is the major product? How that can be decided? That is based on the Saytzeff rule. So if you look at the substitution, 1-butene belongs to the class of monosubstituted alkene. So consider the carbon-carbon double bond system. Across this system, this ethyl group is present. Okay, so that means only one alkyl group is present across the doubly bonded carbon atoms. That is why 1-butene is an example for monosubstituted alkene. Now coming to the 2-butene, across this carbon-carbon double bond system, it contains 2 alkyl groups, methyl groups. Okay, that means it is an example for disubstituted alkene. And we have seen in case of Saytzeff rule that highly substituted alkene is the preferred product. So disubstituted alkene is preferred over monosubstituted alkene. That is the reason 2-butene will be formed as major product in this reaction. That is dehydration of 2-butanol. We get 2-butene as the major product. Now coming to the example 2, dehydrohalogenation of alkyl halides. So here I have considered 2-bromobutane as an example. So dehydrohalogenation means removal of both hydrogen and halogen occurs in the structure of alkyl halides. And this dehydrohalogenation occurs usually in the presence of strong base like sodium hydroxide or potassium hydroxide. In this reaction, bromine is removed from second carbon atom along with the bonded pair of electrons. Coming to the removal of hydrogen, base can abstract the hydrogen from first carbon atom or it can abstract the hydrogen from the third carbon atom. When base abstract the hydrogen from the first carbon atom, then this carbon-hydrogen bond will migrate to 1 and 2 positions, as a result of which we get 1-butene as the product. On the other hand, when base abstracts hydrogen from third carbon atom, that is this carbon atom, hydrogen is removed and the bonded pair between carbon and hydrogen will be migrating between second and third positions. So in that case, we get 2-butene as the product. Now again here also, whether 1-butene is formed or 2-butene is formed as the major product, that is decided based on the Saytzeff rule. Again, 1-butene belongs to the class of monosubstituted alkene and 2-butene is an example for disubstituted alkene. As per Saytzeff rule, highly substituted alkene is the preferred product. So that is why 2-butene will be formed as major product in this dehydrohalogenation of 2-bromobutane. So how to apply Saytzeff rule? So I have given here step-by-step guide. Step 1. Identify the potential elimination sites in the given structure of either alkyl halide or alcohol. Step number 2. Compare the possible alkenes, like as we have compared in the previous two examples. 1-butene, 2-butene will be formed in those examples. So like that, how many alkenes are formed, how many substituted alkenes are possible. Write down all the possible alkene structures. Step number 3, determine the degree of substitution. As we have done the same exercise in the previous example, 1-butene belongs to the class of monosubstituted alkene and 2-butene belongs to the class of disubstituted alkene. So like that, determine the degree of substitution. Then step number 4, predict the major product based on the stability. Highly substituted alkene is the preferred product because of the greater stability. So in an elimination reaction, whether it can be dehydration or dehydrohalogenation reaction, if there is a chance for the formation of trisubstituted and disubstituted, then obviously trisubstituted alkene takes the precedence. And similarly, in an elimination reaction, if tetrasubstituted product and disubstituted product formation is possible, then a tetrasubstituted alkene will be formed as the major product. So to sum up, Saytzeff rule is your shortcut to predict the most stable alkene product in the elimination reactions. Don't just stop here. Grab a pen and book. Try with these examples yourself. If you want more bite-sized organic chemistry lessons, hit the subscribe button and stay tuned for more videos like this one. See you in the next video. Thank you.